Okay, this is the AB 4-3 review. Calculators are not allowed, and this is number 2. With number 2, I'm asking for the number of distinct zeros, the number of relative extrema, and the number of inflection points that the following functions have. So where people are going to mess up is they are going to list the number of zeros in the original, the number of zeros in the first derivative, and the number of zeros in the second derivative. And they will mess up if they do that because you do not have a relative extrema unless the sign of the first derivative changes, nor do you have an inflection point if the sign of the second derivative does not change. So we have to do sign charts for f prime and f double prime in order to determine the number of these that we're going to have. So if we look at part A, we're interested in the zeros of f, in the zeros of f prime, and in the zeros of f double prime. So the original function we can factor into an x squared minus a 4 and an x squared plus a 1, which would in turn factor to an x minus a 2 and an x plus a 2, and the sum of two squares does not factor. So we can see here that we only have two distinct zeros at positive 2 and negative 2. If we look at the first derivative now, take the derivative of this, I get a 4x cubed minus a 6x. Well, now we can factor out a 2 and an x, and we'll be left with a 2x squared minus a 3, which would be a, let me make sure I did that right, which would give me a 2x times, this is going to give me 2 roots, so that would be a root 2x minus a root 3 and a root 2x plus a root 3. So I will actually get 2 zeros for that one. However, we want to determine whether or not we've got sign changes at each of those. So actually it's 3 of them. So I have one at 0, I have one at a positive root 3 over 2, and I've got one at a negative root 3 over 2. So prior to this, say at negative 5, we can see that this will be a negative number and this will be a positive number, so we'll end up having a negative. In between here, say at negative 1, we'd get a negative here and a negative here, which would give me a positive. After 0, say at positive 1, this is positive, that's negative. And between, or after square root of 3 halves, say at 2, this will be positive and that will be positive. So we can see here that we have a minimum, then we have a maximum, then we have a minimum, because f prime changed from negative to positive, from positive to negative, and then again from negative to positive. So we have 3 relative extrema. For our next one, the second derivative will tell us whether or not we have inflection points. We take the derivative again, which will be a 12x squared minus a 6. We set that equal to 0. That's going to happen when x is plus or minus a half square rooted, which if we do our sign chart for that, prior to this, say at negative 1, we'll have a positive value. In between, say at 0, we'll get a negative, and afterwards, say at 1, we'll again get a positive. So we have 2 changes in sign for our second derivative, which means we have 2 inflection points. So this one was pretty straightforward because every 0 that we found on the first derivative and the second derivative actually generated an extreme value or an inflection point. Where it gets a little tricky is when that doesn't happen. So let's look at part B, where things are a little different. Again, we are going to be looking at f, f prime, and f double prime. So f is x cubed minus 4x squared. My first derivative will be 3x squared minus 8x, and my second derivative will be a 6x minus 8. I need each of these to be 0, and I'm not going to find them until I factor. So if I look here, I can pull out an x squared, and I'm left with an x minus a 4. Here I can pull out an x, and I have a 3x minus an 8. And here I can pull out a 2, and I'm left with a 3x minus 4. This one, I have zeros at 0 and at positive 4. Notice 0 is a double root, but the question asked for distinct roots, so that means the ones that are different from each other. So we only get 2 zeros, even though the original power was 3. We only ended up with 2 zeros. 2 real zeros, I should say. Then for here, f prime, we have x is 0 and x is 8/3. So we can't count them as locations of relative extrema until we've analyzed whether the sign changes or not. So I have 1 at 0, 1 at 8/3. Prior to 0, say at -1, this would be negative and this will be negative, so the whole thing ends up being positive. In between, say at +1, this will be positive, this will be negative, so we'd get a negative. And after 8/3, say at 7, this would be positive, and that also would be positive. So we can see here that we had 2 sign changes in f prime. That's going to generate 2 extrema. And last, we have our second derivative. There's only 1 0 at 4/3, and we double check to ensure that f double prime changes sign there. Prior to 4/3, say at 0, we're going to get a negative. After, say at 10, we get a positive. So we had 1 inflection point. If we look at our final one, part C, we have f of x is x to the 5th plus 5x to the 3rd. So again, we need our first derivative, which is 5x to the 4th plus 15x squared. And we need our second derivative, which is 20x cubed plus 30x. Each of these we need to set equal to 0 to find prospective places where they change sign. We do that by factoring. I can pull out an x cubed, that'll give me an x squared plus a 5. This one I can pull out a 5 and an x squared. That gives me an x squared plus a 3. This one I can pull out a 10 and an x, and I'm left with a 2x squared plus a 3. Now notice these are all sums of squares, so we can't factor them anymore. So if we look at the top, we only get 1 distinct 0. If we look at the first derivative, we again only get 1 real 0, and it's a double root. So when I do the derivative sign chart for f prime, prior to 0, both of these are positive, and after 0, both are positive. So I did not get a sign change in f prime, which means I get 0 extrema, or none. With the inflection points, I see that x equals 0 again is my only 0. And if I go prior to 0, this is negative, this is positive. And if I go after 0, both of these are positive. So on f double prime, I did get a sign change, but I only got one of them, so I have 1 inflection point.